Okay, good morning. Welcome to
FamilyMath198a.
198a. So this morning we watched a little bit more of the Terry Tao lecture. And what did we watch? What part of it did we watch?
We wanted to calculate the orbit of Mars.
Yeah, we wanted to calculate, or he was explaining who calculated how long it took Mars to go around?
The ancient Greeks.
Yeah.
Well, the ancient Greeks didn't quite do it.
It was Copernicus.
Copernicus, there you go. So Copernicus calculated how long Mars took to go around the sun, and it's a very interesting calculation. And he just wrote this equation on the board: omega Earth minus omega Mars equals 1 over 780, right?
Yeah.
We didn't say where that equation came from.
No.
And
We didn't even really say what it meant.
And what does omega stand for?
Right. So we're going to talk about that today, but we're going to start with a slightly different problem that you're a little bit more familiar with. Not that you're necessarily familiar with solving this problem, but you're familiar with clocks, right?
Yeah.
Okay. So this is noon, this is 1, this is 2, this is 3. And so the question we're going to ask goes like this. At noon, the hour hand and the minute hand of the clock are exactly on top of each other.
Yeah.
Okay. What's the next time that those hands are on top of each other? Okay, you understand
Yep.
the question? All right. Do you have any thoughts on how you might approach solving this problem?
Well, we could try to see what possible positions it could be in. We could try to see like the hour positions, which ones would work.
Okay. Well, okay. That's a good idea. What do you think would be a position that would be either work or close to working?
Well, close to working, it doesn't quite work, is when both hands are pointing at the 1.
Okay. So what time is that going to be?
1:05.
Okay. So approximately 1:05.
But the problem is...
It doesn't quite work
Okay.
because the hour hand is a bit past the 1.
Right. Because when did the hour hand point at the 1?
At 1
1
o'clock.
At 1 o'clock. So the hour hand would have moved a little bit.
Yeah.
What's a different time that the hands will be almost pointing in the same direction?
2:10.
Okay, about 2:10.
And then 3:15.
About 3:15. Now, do these approximations get better as you go along, or worse?
They get worse
How come?
because when they're pointing at each other, you keep adding on more time at the end of each hour.
Okay. All right, very interesting. So, for example, at 3:15, the minute hand's pointing at the 3, but the hour hand has gone 1/4 of the way to 4.
Yeah.
So the hour hand might be right there. Okay.
Well, the minute hand moves 12 times as fast as the hour hand.
Ah, okay. Very good observation. So this is nice. I like your problem-solving strategy here. Let's get some simple examples so that we know a little bit about what we're talking about, and then we'll see when we get an answer what it looks like. Okay? So you have an observation. What is it?
It's the minute hand is 12 times as fast.
The minute hand moves, the minute hand moves 12 times as fast. Okay. Let's go to a second movie and explore this. Okay?
Alright.